The year is 1944. Across Europe, the sky belongs to the Allies. American bombers fly in tight formations during daylight hours, while British Lancasters and Halifaxes prowl at night. German pilots rise to meet them, but the fight is increasingly hopeless. The Luftwaffe's conventional fighters, the Messerschmitt Bf 109, and the Focke-Wulf Ebu 190, are fast, maneuverable, and well-armed. But they are yesterday's technology. Germany is losing control of its own airspace. In this moment of desperation, as Nazi Germany faces the inevitable closing of an iron vise, two brothers, Reimar and Walter Horton, are working on something extraordinary. Not in some vast government facility, not in a major industrial complex, but in small workshops and hangars. They are building an aircraft that seems to come from another world entirely. It is sleek, revolutionary, and completely unlike anything the Luftwaffe or any other air force has ever flown. This aircraft is the Horton Ho 229, and its story is one of visionary thinking, engineering brilliance, and the tragic irony of creating something revolutionary too late to change history. It is a story about two men who refused to accept the conventional wisdom of their time, who challenged every assumption about how an aircraft should be designed and built, and who, in the twilight of their nation's existence, proved that their radical ideas actually worked. This is their story. To understand the Ho 229, we must first understand the Horton brothers and the obsession that consumed them for 2 decades before the war even began. Reimar Horton was born on December 5, 1915, in Bonn, Germany. His younger brother Walter was born 2 years earlier in 1913. They grew up in an era when aviation itself was still in its infancy. The Wright brothers had flown at Kitty Hawk just 12 years before Reimar was born. The technology was primitive, dangerous, and utterly fascinating to anyone with an interest in engineering or mechanics. Unlike most aircraft designers of their generation, the Horton brothers did not emerge from formal military training or prestigious engineering schools. They were largely self-taught. They came to aviation through an almost artistic sensibility. They were obsessed not with incremental improvements to existing designs, but with fundamental questions about how aircraft should be configured. In the 1920s, as they were teenagers and young men, the brothers became convinced of a singular idea. The most efficient aircraft possible would be one in which the distinction between wing and fuselage essentially disappeared. They envisioned an aircraft that was, in essence, all wing. No fuselage sticking out, creating drag. No tail surfaces creating unnecessary lift and drag. Just a carefully shaped wing that flew through the air like a living thing. This concept was not new. Aviation pioneers had toyed with flying wing designs since the beginning of flight, but most had concluded that such designs were impractical. A flying wing would be unstable, they said. It would be impossible to control. It would require engine placements that were problematic. It was a dead-end idea, a curiosity that belonged in theoretical discussions, not in real aircraft. The Horton brothers disagreed, and they decided to prove it. In the early 1930s, they began building their first flying wings. These were small experimental aircraft, often powered by single-piston engines of modest power. The first Horton flying wing, the Ho-I, flew in 1933. It was crude by later standards, but it flew. And it demonstrated the basic principle that a flying wing could actually stay in the air and be controlled by a pilot. Throughout the mid to late 1930s, the brothers refined their designs. The Ho-2 appeared in 1935, the Ho-3 in 1937, the Ho-Fu and Ho-V following in subsequent years. Each design was more sophisticated than the last. Each one incorporated new understanding about wing design, about control systems, about structural engineering. They experimented with different wing planforms, different shapes and configurations. They tested different engine placements. They developed new approaches to achieving stability and control without conventional tail surfaces. By the late 1930s, the Horton brothers had proven something remarkable. Their flying wing designs actually worked. More than that, they worked well. They were stable, they were controllable, and they were efficient. They generated genuine interest from aviation authorities in Germany, the German Air Ministry, the Reichsluftfahrtministerium, or RLM, began paying attention to the Horton brothers' work. Here were two visionary designers who had developed something genuinely novel. The RLM recognized that in a future conflict, Germany would need to innovate aggressively to maintain military advantage. The Horton brothers' flying wing concept seemed like exactly the kind of radical innovation that might provide that edge. By 1939, as Germany was preparing for war, the Horton brothers had established themselves as serious innovators in the aviation field. They had proven their concept. They had demonstrated that their ideas were not theoretical fantasies, but actual flying aircraft. And now, as war began, they were about to get the opportunity to prove themselves on the grandest stage of all. As the Second World War progressed, through the early 1940s, Germany's air situation was changing dramatically. In the first years of the conflict, from 1939 through 1941, the Luftwaffe had enjoyed clear superiority over its opponents. German fighters, the Bf-109 and Fw-190, were superior to the fighters that the British and Americans were flying. German pilots were experienced, well-trained, and often flew in superior numbers. But by 1943, the situation had transformed completely. American long-range bombers, the B-17 Flying Fortress, and the B-24 Liberator were appearing over Germany in vast formations, hundreds at a time. They were bombing German cities, German industrial facilities, German airfields. The Luftwaffe was struggling to defend against these bombers. The fighters that had been so effective in the early war were finding it increasingly difficult to shoot down the heavily armed and armored American bombers. Moreover, Allied fighter escorts were becoming more numerous and more capable. The Supermarine Spitfire had improved dramatically. American P-51 Mustangs equipped with drop tanks that extended their range were now escorting bombers all the way to targets deep inside Germany and back. German pilots were finding themselves outmaneuvered, outgunned, and facing opposition they couldn't overcome. The Luftwaffe High Command recognized that conventional solutions were no longer adequate. The existing fighter designs, improved versions of the Bf-109 and a fellow 190, could not match the performance that would be needed to regain air superiority. Something fundamentally new was required. In 1941, the RLM issued a specification for a revolutionary, new fighter aircraft. The requirements were ambitious to the point of seeming impossible. The aircraft needed to be powered by jet engines, then still in their infancy and unreliable. It needed to be extremely fast, capable of speeds exceeding 500 miles per hour at altitude. It needed to be highly maneuverable. It needed to carry sufficient firepower to shoot down bombers. It needed to have excellent range and endurance, and it needed to be capable of being produced in meaningful numbers despite Germany's deteriorating industrial capacity and material shortages. This was a tall order for any design, but for the Horton brothers, it was an opportunity to apply their flying wing concept to a fighter aircraft powered by the most advanced propulsion technology available. The Hortons submitted their proposal to the RLM in 1942. The design they proposed was radical. It was a jet-powered flying wing, designated the Ho 229, or sometimes the Ho 9. The aircraft would be powered by two Junkers Jumo 04 jet engines, which were among the most advanced turbojet engines in the world at the time. Though still plagued by reliability issues, the design incorporated all of the lessons the Hortons had learned from their 2 decades of flying wing research. The entire aircraft was essentially one integrated wing structure. There was no distinct fuselage. There was no tail. The jet engines would be embedded within the wing structure itself. The cockpit would be positioned in the center of the wing. The landing gear would retract into the wing. Every system, every component would be integrated into the overall flying wing design to minimize drag and weight. The RLM was impressed. Here was a design that seemed to offer genuine advances in performance and efficiency. Here was a proposal from designers who had actually proven that their concept worked. On August 8, 1943, the project was officially approved. The Hortons were authorized to proceed with construction of prototypes. Building the Ho 229 presented engineering challenges that were almost incomprehensibly complex. Designers and engineers today, equipped with computer modeling and sophisticated manufacturing techniques, would struggle with some of the problems that the Horton brothers faced. In the 1940s, armed with slide rules and hand-drawn blueprints, the challenges seemed nearly insurmountable. Let us consider first the fundamental aerodynamic problem. A conventional aircraft has several distinct surfaces that serve different purposes. The wings generate lift. The fuselage carries the cargo, the fuel, and the crew. The tail surfaces, the vertical stabilizer and the horizontal stabilizer, provide directional control and pitch control. This arrangement is inherently stable. The geometry of the aircraft naturally tends to right itself if disturbed. A flying wing, by contrast, has no distinct tail surfaces. Every element of the aircraft must contribute to both lift and control. This creates what aeronautical engineers call a control authority problem. The surfaces that control pitch, roll, and yaw must be carefully designed and positioned to be effective. Too little authority in the aircraft cannot be controlled. Too much authority in the wrong place, and the aircraft becomes unstable or difficult to fly. The Hortons addressed this problem through a sophisticated arrangement of control surfaces. The leading edges of the flying wing were fitted with slats, movable surfaces that could be deflected to provide both pitch and roll control. These surfaces were called elevons. The wingtips were curved upward, creating vertical surfaces that could provide yaw control. By carefully choreographing the movement of these surfaces, the aircraft could be maneuvered in 3 dimensions without a conventional tail. This sounds relatively simple when described in a few sentences. In practice, it required an enormous amount of wind tunnel testing, theoretical analysis, and refinement. The Hortons worked with the German aeronautical establishment, conducting tests and refining their control surface designs. Every aspect of the geometry had to be calculated precisely. A small error in the position of a control surface could render the aircraft unflyable. The second major challenge was the structural design. An aircraft that is all-wing requires a fundamentally different structural approach than a conventional aircraft. In a normal aircraft, the fuselage is a strong central spine to which wings are attached. A flying wing has no such spine. The entire structure must be capable of carrying all of the loads, the weight of the aircraft itself, the engines, the fuel, the pilot, the weapons, distributed throughout the wing structure. The Hortons chose to construct the Ho 229 primarily from wood. This was partly a practical necessity. By the 1940s, Germany was facing severe aluminum shortages, the light metal that had been abundant in the early war years was now desperately needed for other military applications. The supply was rationed, and aircraft manufacturers had to economize ruthlessly. But the choice of wood was not simply a compromise born of necessity. The Hortons recognized that wood offered advantages. It was lighter than aluminum for equivalent strength. Germany had a strong tradition of wooden aircraft construction. Many aircraft manufacturers were experienced in working with wood, and importantly, wood could be worked with the kinds of tools and manufacturing techniques that were available in 1940s Germany. The Ho 229's wooden structure was not simple plywood. It was a carefully engineered composite. The primary structure consisted of a wooden frame made from specially selected timber. This frame was covered with multiple layers of material. First a layer of balsa wood, then a layer of birch plywood. Between these layers, and as a final covering, was applied a special material that would have lasting historical significance. This material was a coating made from a mixture of sawdust, wood fibers, and glue. More importantly, it contained carbon dust or graphite powder mixed into the matrix. The Germans had discovered through their signals intelligence and experimental work that this carbon-impregnated covering could absorb radio waves. This meant that the Ho 229 would have a reduced radar signature compared to conventional metal aircraft. The Ho 229 was not a stealth aircraft in the modern sense. The radar-absorbing properties of the coating were limited, but it represented something extraordinary. the first deliberate attempt to design an aircraft with reduced radar detectability. This was happening in 1943 and 1944, decades before stealth technology became a major focus of military aviation. The Hortons and the German engineers working with them had identified and were attempting to address a problem that would become central to military aviation in the jet age. The cockpit design presented its own set of challenges. In a conventional fighter, the pilot sits in a fuselage, typically toward the front of the aircraft, where visibility is excellent in most directions. In the Ho 229, the pilot sits in the middle of a flat wing. Visibility becomes a critical issue. The pilot cannot see directly below the aircraft. Forward visibility is good, but rearward visibility is limited. The Germans addressed this through careful positioning of the cockpit and the design of the canopy, but it remained a compromise. The engine integration was perhaps the most complex problem of all. The Junkers Jumo 04 turbojet engines were large, powerful, and produced enormous amounts of heat. These engines had to be fitted inside the wing structure. Embedded within the aircraft's body, the air intakes had to be designed to provide the engines with a smooth, uninterrupted flow of air. The intake design is critical for jet engine performance. An intake that doesn't provide smooth air can cause the engine to stall or surge, creating catastrophic problems. Moreover, the engines produced hot exhaust gases that could exceed 800 degrees Celsius. These exhaust gases had to be routed safely through the wooden wing structure without igniting the wood or damaging nearby systems. Innovative cooling solutions and careful routing of the exhaust pipes were essential. The fuel system was another area requiring careful engineering. The Ho 229 would require substantial quantities of fuel to achieve the range that the Luftwaffe demanded. This fuel had to be distributed throughout the wing in a way that maintained the aircraft's center of gravity as fuel was consumed during flight. The fuel system required numerous small fuel cells distributed throughout the wing, connected by a complex network of pipes and controlled by fuel management systems. The landing gear presented yet another challenge. A conventional aircraft has landing gear attached to the fuselage via substantial shock-absorbing struts. The Ho 229, having no conventional fuselage, required a completely different approach. The landing gear had to retract into the thin wing structure. The design called for the gear to compress dramatically when retracted. This required specialized hydraulic systems and careful geometric design to ensure that the gear could be reliably extended and retracted. Despite the tight confines, all of these systems, aerodynamic, control, structural integrity, engine cooling, fuel management, landing gear operation, had to work together perfectly. A failure in any system could render the aircraft unflyable or dangerous. Yet all of this had to be achieved in an aircraft that was fundamentally different from anything that had been built before, with the design approved and the technical challenges being addressed through development work. The next phase of the Ho 229 program involved actually building the aircraft. This proved to be almost as challenging as the design work itself. The primary manufacturing contractor for the Ho 229 was the Gothair Wagon Fabrik, a company with considerable experience in aircraft production. Gotha had built fighters for the Luftwaffe during the war. They had experience with both metal and wood construction. They seemed like a logical choice to produce the flying wing fighters. But the manufacturing requirements for the Ho 229 were unlike anything Gotha had previously undertaken. Every component of the aircraft required precision woodworking of an extraordinarily high standard. The wooden frame had to be constructed with tolerances measured in millimeters. Every joint had to be precise. Every piece of plywood or balsa had to be cut to exact specifications. The German aircraft industry of the 1940s was not equipped with the computerized machinery and precision manufacturing systems that modern factories take for granted. Skilled craftsmen, armed with hand tools and careful measurements, had to shape and fit thousands of pieces of wood. The process was labor-intensive, time-consuming, and required a level of precision that was rare even by the standards of wartime aircraft production, the graphite-impregnated coating that gave the Ho-229 its radar-absorbing properties presented additional manufacturing challenges. This coating had to be applied uniformly across the entire surface of the aircraft. The proportions of sawdust, wood, fibers, glue, and graphite powder had to be carefully controlled to ensure consistent properties. The application process was tedious and required skilled workers. Moreover, the material situation in Germany was deteriorating rapidly as the war progressed. The war was going badly for Germany. By late 1943 and into 1944, Allied bombing was destroying factories and disrupting supply lines. Shortages of everything from raw materials to skilled labor were becoming critical. Resources that might have gone to Ho-229 production were being diverted to more immediately pressing military needs. The production schedule slipped. The first prototype, which was initially scheduled to be completed in late 1943, was still not finished in early 1945. The second prototype, which was supposed to incorporate the jet engines and fly with them, was even further behind. Gotha was producing the aircraft, but slowly, hampered by the deteriorating situation, the complexity of the design, and the competing demands on German industrial resources. This production slowdown would prove to be historically significant. The Ho-229 would never achieve the production numbers that the Luftwaffe had hoped for. Instead of hundreds of aircraft rolling off production lines, only a handful of airframes would be completed. The program that was supposed to provide a radical new advantage to the Luftwaffe would instead produce only a handful of research and development aircraft. By the beginning of 1945, the first Ho-229 prototype was nearing completion. However, it was not equipped with the jet engines that were central to the design's purpose. Instead, the RLM had decided that the aircraft should first be tested with conventional piston engines. There were several practical reasons for this decision. First, the Junkers Jumo 004 jet engines were still in short supply. These engines were desperately needed for the Me-262 jet fighter, which was the Luftwaffe's primary focus in terms of jet fighter development. The Me-262 was simpler than the Ho-229, and its development was further along. Jet engines could not be spared for Ho-229 research when the Me-262 program needed them. Second, flying a completely untested aircraft design with revolutionary engine placement and control systems for the first time with jet engines seemed unnecessarily risky. If something went wrong during the initial flights, having conventional piston engines would reduce the complexity of the problem. The aircraft could be tested and refined with piston engines, and then once its basic airworthiness was established, jet engines could be fitted. Accordingly, the first Ho-229 prototype was fitted with two piston engines, a Junkers Jumo 203 and a Daimler-Benz DB603. These were powerful, reliable engines. By the standards of the time, though far less powerful than the jet engines that would later power the design. A single propeller would be driven by both engines through a complex synchronization mechanism. The pilot selected for the initial test flights was Erwin Ziller, a highly experienced test pilot who had flown numerous aircraft types and had experience with experimental designs. Ziller was familiar with the Ho-229 program and understood the significance of what he was about to attempt. On March 2, 1945, according to most historical accounts, Erwin Ziller took the Ho-229 up for its first flight. The location was near Oranienburg, in Brandenburg. Not far from Berlin, the aircraft lifted off the ground and flew. The moment was extraordinary. After more than 2 decades of development, after years of wind tunnel testing and theoretical analysis, after enormous engineering effort and expenditure of resources, the Horton brothers' flying wing concept had been proven in flight. The initial test flights were remarkably successful. Ziller reported that the aircraft handled beautifully. The control response was crisp and immediate. The aircraft was stable in flight. There was no tendency to diverge into uncontrollable motions. The aerodynamic principles that the Hortons had developed, through years of research actually, worked in practice. Subsequent test flights were equally encouraging. The aircraft proved to be maneuverable. It could be rolled, pitched, and yawed smoothly. The handling characteristics were, by all accounts, superior to conventional fighters of the era. Test pilots remarked that the aircraft was easy to fly, responsive to control inputs, and stable throughout its flight. Envelope. Performance data from the test flights showed that the aircraft was remarkably efficient. With piston engines, it achieved speeds that were respectable for 1945, though not exceptional. But the efficiency of the design was evident. The low drag of the flying wing configuration was producing performance that conventional designers said should not have been possible. The success of these initial flights energized the program. Plans were made to complete the second prototype, which would be fitted with the Junkers Jumo 004 jet engines. Performance projections suggested that with jet power, the Ho 229 could achieve speeds of 550 to 600 miles per hour, faster than most conventional fighters, then in service, and potentially faster than the contemporary Supermarine Spitfire or North American P-51 Mustang. The rate of climb with jet engines was projected to be exceptional, over 11,000 feet per minute, which would give the aircraft a significant advantage in combat. The aircraft's efficiency would also translate into excellent range and endurance. For the first time, it seemed that the Hortons' radical vision might actually produce a fighter that could make a real difference in the desperate air war over Germany. But time, which had been the enemy throughout the Ho 229 program, was about to become the ultimate victor over the project. In April 1945, as the Ho 229 test program was gathering momentum, and as plans were being made to complete the jet-powered version, Nazi Germany faced its final catastrophe. The Soviet army, advancing from the east, was closing in on Berlin and the industrial heartland of Germany. The American and British armies, advancing from the west, were rapidly overrunning German territory. The Wehrmacht was in collapse. The Luftwaffe was essentially ceasing to exist as an organized fighting force. The facility where the Ho 229 was being developed and tested came under direct threat. As the Soviet army approached, German military authorities faced a stark choice: either evacuate the Ho 229 program or destroy it to prevent it from falling into enemy hands. In the final days of the war in Europe, as German military commanders faced the reality of defeat, decisions had to be made about what could be saved and what had to be destroyed. The Ho 229 prototype aircraft, which represented the culmination of decades of Horton brothers research and engineering effort, was marked for destruction. The aircraft was deliberately destroyed or damaged beyond repair. Historical accounts suggest that the first prototype, which had successfully flown, was either burned or partially dismantled. The second prototype, which was nearing completion, was destroyed or left incomplete. The developmental drawings, design, documents, wind tunnel data, and technical files were either destroyed or scattered as the German military collapsed. It was a tragic conclusion to what had been an extraordinary engineering achievement. The Ho 229, which had proven itself to be a viable and promising fighter design, would never see operational service. The jet-powered variants that might have demonstrated the full potential of the design would never be completed. The revolutionary aircraft remained forever an incomplete achievement, a glimpse of what might have been a technological achievement that came too late to influence the outcome of the war. Germany surrendered unconditionally on May 7, 1945. The war in Europe was over. The Ho 229 program, along with so many other ambitious German technical projects, had been extinguished in the chaos of the final collapse. In the months and years immediately following the end of World War II, American military authorities conducted extensive investigations of German technical achievements. The American military recognized that there was much to be learned from German research, development, and engineering efforts. American teams of specialists searched through the rubble of German facilities interviewed German engineers and scientists, and collected whatever documents, equipment, and hardware they could find. Among the discoveries made by these teams was the Ho 229. One of the damaged prototypes was found in Germany and was recovered by American forces. The aircraft, though incomplete and damaged, was carefully transported to the United States for analysis and study. When American aircraft designers and aeronautical engineers examined the Ho 229, they were astonished. Here was an aircraft that represented advanced thinking about aerodynamics and aircraft design. Here was proof that a flying wing fighter was not merely a theoretical possibility, but could actually be engineered and flown. Here was evidence that the Horton brothers had indeed been visionary designers, working decades ahead of conventional aviation thinking. The significance of the Ho 229 became immediately apparent to American aviation authorities. The concept of a flying wing fighter was revolutionary. The integration of jet engines into the airframe was sophisticated. The whole design philosophy represented a different way of thinking about aircraft that American designers found both intriguing and validating, because there were American aircraft designers who had been thinking along similar lines. Specifically, the American aircraft manufacturer Northrop had been experimenting with flying wing designs since the 1930s. Jack Northrop, the founder and chief designer of the Northrop Corporation, shared the Horton brothers' conviction that the flying wing represented the future of aircraft design. Northrop had been working on flying wing designs, and the discovery of the Ho 229 provided additional evidence that the concept was sound. The American military, particularly the Army Air Forces, became intensely interested in the flying wing concept. Here was a design that offered dramatic improvements in efficiency, range of Mach, and potential performance compared to conventional aircraft designs for a nation that was now engaged in the Cold War and needed long-range strategic bombers that could deliver atomic weapons to targets in the Soviet Union. The flying wing offered obvious advantages. Moreover, the Ho 229 provided specific technical insights that would influence American aircraft design. The Horton brothers' approach to control surface design, their methods for integrating engines into the airframe, their structural design principles, all of these became subjects of intense study and analysis. The discovery of the Ho 229 also brought the Horton brothers themselves to the attention of the American aviation community. Reimar Horton, who had survived the war, was eventually located. American military authorities recognized the value of his knowledge and experience. After the war, Reimar eventually emigrated to Argentina, where he continued his work on aircraft design, including additional flying wing designs. The influence of the Ho 229 and the Horton brothers' flying wing research on American aviation was profound and lasting. In the late 1940s, as Cold War tensions increased and the American military sought advanced new aircraft designs, the flying wing concept became an active area of development. Northrop Aircraft, under the leadership of Jack Northrop, developed the B-49 flying wing strategic bomber. The B-49 was a large, jet-powered bomber designed to carry atomic weapons. It incorporated many of the aerodynamic principles that the Horton brothers had pioneered. The aircraft was impressive, a sleek, elegant design that looked like it had come from the future. In the late 1940s, the B-49 represented the cutting edge of American bomber technology. However, the B-49 program ultimately did not produce the quantities of aircraft that had been hoped. Only 2 prototypes were built. There were technical challenges, political considerations, and the existence of alternative bomber designs that competed for development, resources, and funding. The B-49 remains one of aviation's might-have-beens, a brilliant design that came close to becoming operational, but ultimately never did. Nonetheless, the concept of the flying wing continued to develop. Through subsequent decades, various military organizations continued to experiment with flying wing designs. These designs were used in reconnaissance aircraft, in experimental vehicles designed to test radical concepts, and in classified military programs, whose details remained secret for decades. The most famous result of the flying wing research lineage that traces directly back to the Horton brothers and the Ho 229 is the Northrop B-2 Spirit stealth bomber. The B-2, which first flew in 1989 and has been in operational service with the United States Air Force since the 1990s, is a flying wing. It represents the ultimate refinement of the concept that the Horton brothers first demonstrated in the 1930s and proved with the Ho 229 in 1945. The B-2 incorporates not just the elegant aerodynamics that the Hortons had envisioned, but also radar-absorbing technologies that take the Ho 229's carbon-impregnated coating concept to a vastly more sophisticated level. The B-2's entire design is shaped and configured to minimize its radar signature. The aircraft is essentially invisible to conventional radar systems. This represents a remarkable historical lineage. From the Horton brothers' first flying wing experiments in the 1930s to the revolutionary Ho 229 in 1945 to the American research programs of the 1950s and 1960s to finally the B-2 Spirit, one of the most advanced military aircraft ever built. That lineage demonstrates the power and persistence of a good idea, even when its initial expression is interrupted by war and defeat. The aeronautical principles developed by the Horton brothers, principles of efficiency, of integrating all aircraft systems into a unified design, of thinking radically about conventional assumptions, have proven so sound that they are still being applied in modern aircraft design. Modern flying wing concepts being researched today, including both military and civilian applications, trace their lineage back to the Horton brothers' fundamental insights. The post-war fates of the two brothers were quite different. Reimar Horton, as mentioned, survived the war, and his expertise was eventually recognized by the American military and aerospace industry. After spending some time in Europe, immediately after the war, Reimar emigrated to Argentina in 1946. He continued his work in aircraft design, working for the Argentine aircraft industry and developing additional flying wing designs. He founded his own design bureau and continued to pursue the flying wing concept well into his later years. Reimar lived for many decades after the war, finally passing away in 1994. At an advanced age, he saw the fruition of his life's work in the development of the B-2 Spirit and the eventual vindication of all the principles that he and his brother had fought to establish. In his later years, Reimar was recognized by aviation historians as a visionary whose ideas had been proven correct by history. He gave lectures and interviews about his work and about the development of the Ho 229. By the end of his life, Reimar Horton was widely recognized as one of the most important aircraft designers of the 20th century. Walter Horton did not enjoy the same post-war recognition and success. Walter did not survive the immediate post-war period in good health. He did not have the opportunities that Reimar had to develop his career in Argentina or elsewhere. While details about Walter's post-war life are less well documented than those of his brother, what is clear is that Walter did not achieve the recognition or continue the professional accomplishments that Reimar did. Nonetheless, the contributions of both brothers to aeronautical engineering are substantial and lasting. Together, they pioneered a design philosophy that has proven to be correct and durable. Their willingness to challenge conventional wisdom, their persistence in pursuing an idea that most of their contemporaries dismissed as impractical, and their engineering brilliance in bringing that idea to fruition, all of these qualities mark them as extraordinary figures in the history of aviation. To fully appreciate the significance of the Ho 229, it is necessary to understand its place in the history of aviation and military technology. The aircraft represented several firsts that are of lasting historical significance. First, the Ho 229 was the first jet-powered flying wing fighter ever designed and flown. The concept was radical. Most aircraft designers in the 1940s assumed that jet fighters would follow conventional configurations. A fuselage with wings attached, tail surfaces for control. The Horton brothers rejected this assumption and applied jet propulsion to their revolutionary flying wing concept. This represented a synthesis of two cutting-edge technologies in a way that had never been attempted before. Second, the Ho 229 represented an early attempt at deliberately designing an aircraft for reduced radar signature. The graphite-impregnated coating was not stealth technology in the modern sense, but it represented the first conscious effort to design an aircraft with radar-absorbing properties. This was more than half a century before the F-117 Nighthawk stealth fighter, yet the principle was being applied. Third, the Ho 229 demonstrated that extreme aerodynamic efficiency was achievable through radical design thinking. The flying wing configuration with no fuselage and no tail surfaces represented a fundamental challenge to conventional aircraft design philosophy by proving that such a configuration could be flown safely and would deliver superior performance and efficiency. The Hortons opened new possibilities for aircraft designers. Fourth, the Ho 229's manufacturing approach using wood composite construction in an era when metal aircraft were dominant was innovative. While partly driven by material shortages, the choice also reflected sophisticated thinking about structural design. The wooden airframe with its carefully engineered composite construction proved to be effective, light, and structurally sound. The Ho 229 also represents a poignant historical irony. It was a revolutionary aircraft designed for Nazi Germany, developed by brilliant engineers under a totalitarian regime engaged in aggressive war. Yet the aircraft's revolutionary design principles proved so sound that they have influenced aviation development in free societies for decades after the war's end. The ideas transcended the political and moral context in which they were created. From a purely technical standpoint, the Ho 229 also represents a moment when engineering creativity exceeded the resources available to realize that creativity. Given adequate resources, proper manufacturing facilities, and a longer development timeline, the Ho 229 program might have produced a fighter that could have been operationally significant in the later stages of the European War, but that scenario existed only in the realm of possibility. In historical reality, the Ho 229 was constrained by German industrial decline and the inexorable advance of the Allies. The Horton Ho 229 stands as a testament to human ingenuity and visionary thinking. It represents what can be achieved when brilliant minds refuse to accept conventional wisdom and pursue radical ideas with determination and skill. The aircraft's legacy lives on in every flying wing that takes to the skies, in every stealth aircraft that evades radar detection, and in the continuing pursuit of aerodynamic efficiency that drives aviation forward. From the workshops of two self-taught German brothers in the 1930s to the cutting edge of modern military aviation, the flying wing concept has proven its worth. The Ho 229 may have been born too late to change the outcome of World War II, but its influence on aviation history has been profound and enduring. This was an aircraft ahead of its time, a revolutionary design that pointed the way to the future and a lasting tribute to the vision and brilliance of Reimar and Walter Horton. Their story reminds us that great ideas can emerge from unexpected places, that persistence in the face of skepticism can be rewarded, and that engineering excellence can transcend the circumstances of its creation. The Horton Ho 229 was more than just an aircraft. It was a glimpse into the future of aviation, a promise of what was possible when imagination met engineering, and a legacy that continues to inspire designers and engineers to this day. This has been the story of the Horton Ho 229, a revolutionary aircraft, two visionary brothers, and an idea that changed aviation forever.